Hello, mathematicians. Today we're going to be learning about slope-intercept form. So we know that slope-intercept form is represented by the equation y equals mx plus b. So the variable m represents slope, which we also know as the rate of change. And our variable b represents the y-intercept where the line crosses the y-axis at 0b. So here in our equation, b represents the value that our line will cross the y-axis. And we also know this as our initial value. So here we have a problem. Casey's computer has 200 gigabytes of space, and every year she uses 20 gigabytes of space. So initially, her computer started off with 200 gigabytes, so this is our initial value that we also know as our y-intercept. And then every year she uses 20 gigabytes of space. So this is our slope because it's the rate that she is using her gigabytes. So this is our slope. And if we're going to write an equation in slope-intercept form, we're going to start off with y equals. So y represents the gigabytes the computer has. So y equals, and she uses 20 gigabytes of space. So we're going to take away 20 gigabytes of space each time. So the rate is actually negative 20. X for each year. And then we're going to add the initial value that her computer started off with. So plus 200 gigabytes. So be mindful that the negative 20 is because she uses 20 gigabytes every year. Okay, so 20, it's negative 20 over 1 because she's using the gigabytes. And then X represents the years plus 200, which is our initial value. So we can make a table to represent the relationship between the years and the gigabytes. So we know that X is the number of years, and Y represents the gigabytes. So at 0 years, when she first got her computer, it had 200 gigabytes. After 1 year, she used up 20 gigabytes, so it's now at 180. And then after 2 years, she used an additional 20 gigabytes, so it would now be at 160. And after 3 years, it would now be at 140, and so on. Just be mindful that you could continue on with your table, even though I don't. So here, we're decreasing 20 for a y value because each year that passes, she's using 20 gigabytes worth of her computer. So each year that passes, she uses 20 gigabytes. And if we're going to plot that, we're going to start off at 0, 200 because her computer started off with 200 gigabytes. And then we're going to represent her loss of 20 gigabytes each year. And I'm going to draw my line through that. So you'll notice that our line is decreasing, and that's because with every year that's passing, she has less and less gigabytes on her computer. And so if we wanted to to use 2 points to represent our slope, we could use any 2 points. So let's say this one, for example. From this point to this point, we're decreasing 20 gigabytes because that's from 160 to 140, and that's in the span of a year. Or we could pick 2 other points, let's say these 2, and you'll notice that from this coordinate to this coordinate, we're decreasing 20, 40, 60 gigabytes in the span of 3 years, and negative 20 over 1 is equivalent to negative 60 over 3 because this represents that she's using 60 gigabytes in 3 years, which is 20 gigabytes per year. So just be mindful that if you're looking at slope using your line, that you simplify. And here we have our y-intercept because we started off with 200 gigabytes. And here we also have our x-intercept because this is where our line intercepts the x-axis. So here we have our x-intercept. And our coordinate here is 10, 0. And this represents that after 10 years, her computer will have 0 gigabytes on it because she would have used all the space. So let's look at another example. Here it says that Sarah is on the 12th floor and she walks down 4 flights of steps every 3 minutes. So the 12th floor is where she's at. So this is our initial value, which we also know as our y-intercept. And walking down 4 flights of steps every 3 minutes. Well, walking down, that's important because she's going down. This is our rate of change, which is our slope. And here, again, in slope-intercept form, we represent it using y equals because y will tell us the flight of step, the floor that she's on, and y equals she's decreasing 4 flights of steps every 3 minutes, so it's going to be negative 4 over 3 x, and then she's on the 12th floor, so we're going to add 12. So here we have y equals negative 4 over 3x plus 12. And so now we're going to make a table to represent this. So minutes is our x, and the floor we're at is our y. And so at 0 minutes before she starts going down the steps, she's on the 12th floor. And she's decreasing 4 flights of steps every 3 minutes. So every 3 minutes, she's going down 4 floors. So that puts us at the 8th floor. And then another 3 minutes passed, and then she goes down another 4, putting her on the 4th floor. And then another 3 minutes pass, and she goes down another 4 flights of steps, which puts her at 0. So here you'll notice that the y is decreasing by 4, which is our numerator here because it's the flight of steps that she's going down by every 3 minutes. So our minutes are increasing. So she initially starts off at 0, 12, and then she goes down 4 floors every 3 minutes. So she goes down another 4 floors in 3 minutes. And then she goes down another 4 floors in 3 minutes. So here if we pick any 2 coordinates, you'll see that there's a decrease of 4 because we're going from 8 to 4 and 3 minutes. And the same would be true if you picked another 2 points. If we started here and we went down here, that would be -4 over 6. So any 2 points that you get would give us our slope. So -4 over 3. Just be mindful to simplify if we can. In this case, we can't. We could just leave it as -4 over 3. And our y-intercept is over here because she started off on the 12th floor. And that's at 0, 12. And then here we have our x-intercept. Which is at 9, 0. Because after 9 minutes, she's on ground level. So that means she went down all the steps. And that's it.